Hello everyone, my name is Quinn, and this is the first part of a series I'm creating to showcase some of the projects I've been working on. The first project was one I worked on at Lendica, a company that streamlines the small business loan underwriting process using advanced quantitative and AI-assisted techniques. My task at Lendica was to create Jobin, an AI agent swarm tasked with the goal of categorizing financial transactions as revenue or non-revenue items. Jobin leverages the categorization and reasoning abilities of state-of-the-art open-source LLMs, such as Meta's Llama 370 billion, to classify transactions based on limited information. The information given on each transaction is very sparse, limited to the name of the transaction, its amount, and the account that it comes from. The structure of Jobin follows a hierarchical agent swarm architecture. The most abstract agents in the swarm are the main agent and memory agent. The main agent is the agent that is responsible for communicating with the user and determining how to route tasks to different agents. It requires the most advanced reasoning abilities, so it utilizes GPT-4 as its reasoning engine. The other top-level agent is the memory agent. The memory agent is intended to facilitate communication between the different agents in the swarm in a decentralized manner. This agent is also supposed to enable long-term memory for advanced planning capabilities for the swarm, which should be implemented at a later stage. Once the main agent understands the goal that the user has given it, it then communicates directly with its subservient agents, the task delegator. The task delegator is an agent that breaks up the task from the main agent into simpler subtasks, which are then delegated to lower-level agents in the swarm. In the future, the task delegator will be given the ability to spawn bespoke agents that are optimized for certain subtasks. At the current stage of the swarm, the only type of agent below the task delegator are the revenue agents. The revenue agents are based on Llama 370 billion, which is one of the most advanced open-source LLMs available today in terms of reasoning ability. Each revenue agent is assigned a month's worth of company's transactions, which it then goes through line by line and categorizes each transaction as revenue or non-revenue. Once the revenue agents have categorized all the transactions, they send their output to the sum agents. The sum agents are simple agents that utilize GPT 3.5 in order to determine the total amount of monthly revenue based on the output of each revenue agent. The reason GPT 3.5 is used for this agent is because it doesn't require advanced reasoning abilities, it only needs to be able to use tools to sum up all the revenue items. Now I will showcase the usage of Jobin on real company data. The first step is to specify the path where Jobin must look for a CSV file containing a list of raw transactions. The CSV file doesn't need to follow any special format, as the revenue agents and task delegator agent are able to automatically parse relevant fields from the CSV to enable handling of unique formats. Once Jobin knows where to find the CSV, it is important to give a sentence or two of context on the company. This context is used by the revenue agents to give some context to each transaction to enable better classification logic. Once the first two steps have been completed, the next step is to run the main.py file. This initiates the swarm itself, starting with the higher level agents. Once the swarm has been initialized, the main agent will ask the user for detailed instructions on its task. For this demonstration, I will use a pre-generated prompt that is tailored for this revenue classification task. Once the prompt is sent to the main agent, it then communicates with the task delegator, which then spawns a number of revenue agents. These revenue agents are then given a month worth of transactions to classify. When Jobin was running locally on my workstation, I was able to run the revenue agents asynchronously using VLLM, which greatly sped up the process of revenue classification. Now that we are using RunPod for the agents in the cloud, the agents run sequentially, significantly slowing down the process. There are plans to re-implement the asynchronous agents in the future. After the revenue agents have classified a year's worth of transactions, the output is then sent to a number of sum agents which sum up all the revenue items. These revenue numbers are then sent to the main agent and are also written to a text file which can then be used for analysis. I am really happy with how Jobin has progressed. It has demonstrated the power of agentic AI, and it provides a powerful foundational architecture which can then be used in the future for other tasks. I really appreciate Lendica giving me the opportunity to work on this exciting project and look forward to what the future may hold.